All right, hello everybody, and welcome to what will be Chapter 6, Section 2. So today we're going to be talking all about this method we're going to call substitution. And with this, we will learn how to solve a group of equations differently than we did last time. So what we actually did last time was solve our equations by drawing a visual picture. In other words, by graphing. And today we're going to learn how to solve by using what we're going to call substitution. So at the end of today, the hope is we'll now have two strategies that we can use to solve these problems. And so we'll have one more thing to throw in our tool bag to help us work through these types of scenarios. We'll also see some real-world problems with a little bit of context that tell us how to use this in a couple situations that are less abstract and more concrete. So, vocab for today, we already said, is substitution. So here's a couple steps, or 3 steps, to look at for how to solve by substitution. So first, step 1 says, when necessary, solve at least one equation for one variable. So that means get one variable all alone. Step 2 tells us, substitute what's left from the expression from step 1 into the other equation to replace the variable, and then solve. So that's a lot of wording, but we'll talk about it as we work through it, so just begin thinking about it. And then the last step would be to substitute what you got from step 2 into either equation and solve for the only other variable left. So with these steps, we can solve for both variables given 2 equations. We'll have what's left, a value for x, a value for y. And we can write that as an ordered pair, x comma y. So let's jump into it. Okay. So example 1a. Here we're given 2 equations. They say use substitution to solve the system of equations. So we've got y equals. So this is good because we already have y by itself. And then here we have 2x plus y equals 2. So how are we going to tackle this? So what do we see first? Well, the whole goal with substitution, let's think about what this word substitution means. To substitute means to do what? Well, we're going to say it means to replace. And every time we have an equal sign in our equation, that tells us whatever's on the left is the same as whatever's on the right. In other words, every time I see a y, I can change it to negative 4x plus 12. And I can do that because y is the same as this whole expression. So, if I take this now 2x plus y equals 2, if I'm looking at that, I can change the y here. I can replace the y and instead say, what is y equal to? Well, y is the same as this whole negative 4x plus 12 expression. So in my second equation, I'm going to substitute negative 4x plus 12 for y because those are the same things. So I'm going to rewrite that now. So here's my second equation as we started. And now focusing on the y, I'm going to change it to what it is equal to, negative 4x plus 12. Good. So that is the jump here. That is the big jump for these types of problems that we'll do today. Once you can wrap your head around replacing or substituting one of the variables, it becomes pretty straightforward. So now notice what do we have? We have only x's in our equation. Now if we have one equation and one variable, now we can solve it. And we learned this in first semester, how to solve multi-step equations. So this we already know how to do. We'll simplify and substitute, get everything, do everything that we can to simplify it, and end up with x by itself. So let's do that now. So if we have 2x minus 4x, that's going to be a negative 2x. We still have the plus 12 and we have the 2. So we could subtract 12 from both sides. And negative 2x would equal negative 10. And one more step. To get x by itself, we'll divide both sides by negative 2. If we do that, x will equal, you should be thinking, 10 divided by 2 is 5. And this one is positive because it's negative over negative. They cancel out. So x is 5. But before we begin thinking we're finished with this problem, we are only halfway home because we need to find out what y is. But once you find one variable, the process becomes a lot easier. So we now know x has to be 5. And if x is 5, we can replace x with 5 either in our first equation or in our second equation, whichever one we want, and then we can solve for the only thing left. So let's do that on the next slide. Okay, so let's substitute 5 for x. So say we do it in our first equation, and it would work with either one, but just say for the sake of having to choose one, we use the first equation. So that's what we start with. Now change the x to a 5, and now all we have to do is multiply through, simplify, and our y value is staring us in the face. So we know 5 times 4 is 20, but we have a negative, so we'll keep that. And then negative 20, add 12, the difference there is 8, and it is negative. So y equals a negative 8. Now we already said that x was 5. So if x is 5 and y is a negative 8, what does that mean for our problem? Well, though that is our answer. We have both x and y. And we can actually write that as an ordered pair, which looks like this. One number, comma, the second number. And remember, it's always x, comma, y. For our ordered pairs, it is always the x value first, and then the y value. Of course, we know that from every graphing activity that we've done. X, comma, y in every ordered pair. So there we go. So have down 5, negative 8 for our first example today. Alright, so by similar logic, let's now look at 1b. Here we want to use substitution to solve our system. So we already have a y equals 2x, so y is by itself. So that's always what you want. You want to start with one variable alone, if you can. So since y is the same as 2x, that means I can replace y with 2x in this equation. So I'll circle the things that I'm about to replace. So I know y is the same thing as 2x. So everywhere I see a y, I'm going to write 2x in this equation. So I circled the two things that are about to change. This y is going to become a 2x because it's the same as y given in the first equation. So this equation, I can actually say is the same thing as 3x plus 4 times, and what is y the same as? 2x. I can change my color to just make that a little bit clearer. 2x. Good. Equal to 11. Now from here, it's our ability to solve multi-step equations, just like we did in first semester. So all the things we talked about in the past are going to be coming full circle here as we work through all this content. So here we get 3x plus 4 times 2 is 8 equal to 11. 3x plus 8x is 11x. And if 11 times some number equals 11, what's that some number going to be? Well, it must be 1. So x here is 1. Good. Now we're halfway done. So if x is 1, what must y be? So I can plug into either equation. I know the first equation here is a lot shorter, so I'm going to use that one because we can finish this up pretty quick. So if y equals 2 times some number, but we know that x is now 1, we can just put the 1 there. So we know y equals 2. Great. Now if we know this is the case, we can now write this as an ordered pair. If we remember x comes first, we know our ordered pair should be 1, comma, 2. This will always be a wrong answer option for you when you switch the order of your numbers. Right? So this 2, 1, although it has the right values, they're in the wrong order. So this will always be here to trick you. So you have to absolutely know which one comes first, and it's going to be x. So x and then y. So we know our answer should be letter choice B, 1, comma, 2. So have that and those steps for 1b. And we confirm. Great. So if we can understand that, the rest of this section is very similar, working through problems. But some of them are just a little bit more difficult than others. So let's look at one more where we have to simplify with a couple more steps. We want to use substitution again, but notice neither equation is solved for x or y. So we have to do that work before we can do any substitution. So we want to try to reshape either of these equations with one variable by itself. So if I look at my first equation, I already have only one x here, which is good. But I have this minus 2y next to it, but I can get rid of that just by adding 2y to both sides. So let's do that. First equation given, we add 2y to both sides. Now these y's on the left here will cancel out, and on the right we just get an expression. So now we have just x equal to negative 3 plus 2y. Now why even bother doing this? We had an equation here, we still have another equation, it doesn't look much better. The reason is we have to isolate one variable. That is, we need to get one variable all alone on one side of the equation so that we can substitute whatever it's equal to. So this is much better for substitution than this. So now we know x can be replaced with negative 3 plus 2y. So we can substitute negative 3 plus 2y every time we see an x in our second equation. So this was the equation given as our second one. So the red x here, it's red because we're about to change it to what we know x is equal to, which was this expression here, negative 3 plus 2y. So we'll change that. Now if you can wrap your head around that piece, that is the only difficult aspect of this section. Everything else is review. So now we have to solve our multi-step equation. So we must distribute our 3 to both of these terms. That'll look like this. And now we combine what we can. So we have 6y's and 5y's. That'll be 11y's. And then if we have a minus 9 here, we can go ahead and add 9 to both sides. That'll give us 11y equal to 33. And now if we get y alone, we must divide both sides by 11. So if we do that, then y equals, we should be thinking, is 3. So y must equal 3. So hopefully we have that. Now we're halfway home, we got to find x now, so we'll plug in y, we'll plug in a 3 for y into either equation and find out what x is. Okay, so our first equation was pretty simple, so let's plug in 3 for y in the first one. So where there's a y, we're going to replace it with a 3 that we just found. And now we'll multiply. 2 times 3 is 6. Get x alone, we got to add 6 to both sides to cancel out. And x equals positive 3. So if x is 3 and y is also 3, our ordered pair then for our answer is 3, 3. So there's our solution for this example 2 type problem. So make sure you have down 3, 3, a couple of those steps, and you should be golden as we look for the next example. Okay, so 2b. We want to use our substitution skills that we now have to solve this problem. So we have to do some manipulation here to get one of these equations solved for our variable. So if I want to manipulate the first one, I want to get it and solve it for y. So if I say I added y to both sides here, from this one I add y to both sides. So I get 3x is equal to y minus 12. So to get from here to here, I just added y to both sides. On the left they cancel out, on the right I just get 1y. Now I want the 12 to go away because I want the y by itself. So I'll add 12 to both sides, and y would equal 3x plus 12. Alright, so if y equals 3x plus 12, everywhere there's a y, I can also put 3x plus 12 into the other equation that I have. So let's do that. So if I have negative 4x plus 2 times, well, y is going to be this 3x plus 12 thing, and it's equal to 20. Okay, but instead of the y, I'm going to put what it's equal to, 3x plus 12. And the reason we do that is because we now have an equation that only has x's in it, not x and y, and now we can solve it because it's just a multi-step equation now with one and only one variable. So let's do some distribution, use our skills we learned in the beginning of the year to figure this out. So negative 4x plus 6x plus 24 equal to 20. Awesome. Now we need to combine the x's, so here and here that'll become positive 2x plus 24 equals 20. We'll subtract away 24 on both sides because we don't need this term over here. We want to get the x alone eventually. So let's subtract 24 from both sides, and we'll get 2x is equal to negative 4, and you can type that in a calculator if you don't believe me. And now to get x by itself, divide both sides by 2. So in other words, cut everything in half. So x equals a negative 2. Great. Now if you were to look at your answer choices, you can now tell what the answer must be if x is negative 2. But we can go ahead and quickly double check to make sure we get the right y value. So now we're going to plug in x as a negative 2 into either equation. It looks like the first one is a little bit simpler, so let's do that one. So we have now, we're done with this piece. We have now 3 times negative 2 minus y equals a negative 12. So 3 times 2 is 6, keep the negative, equal to negative 12. If I add 6 to both sides, I'll get negative y is equal to negative 6. I added 6 to both sides, and this became a 0, and this became negative 6. And then if I multiply both sides by negative 1, because I want this to be positive, y equals positive 6. And that is exactly what we see over here. So our answer, x is negative 2, y is positive 6. So A is correct. We have 2, negative 6. That is our 2B problem, done as well as it can be done. So have negative 2, 6 for your notes today as we move to an example 3 type problem. Okay, so for this one, there are 2 cases that are special when you're solving these. Those are cases where you have no solution and cases when you have infinitely many solutions. So we're going to look at what that looks like in terms of algebra. So let's do some substitution. First, we have to solve one of our equations for a variable. So it's all by itself on one side of our equal sign. So the second equation is simpler, so it's faster to manipulate. So we can solve for either or. So say we solve this one for y by subtracting an x on left and right. If we do that, y equals negative 2 minus x. And now we have something we can substitute, right? Everywhere there's a y, we can put now a negative 2 minus x. So we're going to take this expression and use it in our first equation. So everywhere there's a y in my first equation, instead of writing it here as a y, I'm going to write negative 2 minus x right here. And that will give me one equation with only x's, and then we can solve it. So let's see that. Substitute that in. So there's our first equation. Now instead of a y, I'm now going to put what y is equal to, negative 2, take away x. And we did that there. That's the big step here. Replace what you can based on what your variable is equal to. So we know we're looking at replacing the y. And we know here that y is equal to negative 2, take away x. So that's how we know these are the same, because of this expression. So we got from here to here. replace, and substitute. Right. If you can wrap your head around that, the rest of this is just stuff we've already talked about at length. Okay. So on the next slide, now we're going to distribute. So we have this expression here. Distribute the 2, you get negative 4, and here you get a negative 2x. That's how we got this. From here, now just simplify what you can. So the 2x and the negative 2x become a 0, so that they just disappear. And now we have this strange expression that says negative 4 equal to 8. So here's the rub here. If you have no variable, then you just have 2 numbers. Then you have to think about, is it a true statement or is it a lie? If it is a true statement, you have infinitely many solutions. But, as it is in this case, if you have 2 numbers that are not equal, in other words, a lie, you know there is no solution. There's no number that would make negative 4 equal to 8. So, in other words, there is no solution to the system of equations. So make sure you have down no solution for this example 3a problem today. Good, so we're working through that, thinking about this process and figuring it out. So let's say we now look at 3b. So I want to solve one of these for a variable. Let's say I solve the second one for y. So if I'm looking at this one and I add 6x to both sides, I know 4y equals 6x minus 6. If I divide everything by 4, y would equal 3 halves x minus 3 halves. That's just dividing everything by 4. Okay, so if this is the case, I can put in this whole expression for y into my first equation. So everywhere there's a y in my first equation, I'm now going to put what is equal to, because we are allowed to substitute. So I'll rewrite this then. My first equation rewritten will be 3x minus 2y, but instead of y, I'm going to put this whole expression here equal to 3. So let's change our color just to make sure we're on the same page here. Plugging in what y is equal to. 3 halves x minus 3 halves. Now this looks super crazy, but it's going to simplify pretty well for us, and then we'll have our answer. Okay, so we have 3x, we can just bring that down, minus, now we have to distribute this 2 to everything. So we have 2 times 3 halves. So 2 over 2, those cancel out, and we're just left with 3. So this multiplication is actually just 3x. And here we have 2 times 3 halves. Again, the 2's cancel out, we're just left with 3. And this one is positive, because we did negative times a negative. All right. So now that whole wacky fraction thing turned out to simplify pretty well for us. So we have 3x minus 3x, that becomes 0. So we have now 3 equal to 3. I'll rewrite that one more time just so we can look at it. So we have 3 equal to 3. Now we just need to think about, is this a true statement or is it a lie? And with very little effort, we can tell 3 equals 3, that is true. If that is a true statement, we know there are infinitely many solutions. There are infinite solutions to this problem. So there are different ways to say that. You could say all real numbers. You could also say the words infinitely many solutions. So it can be determined, and we know there's an infinite number of answers to this problem. So 3b has to be C, infinitely many, because this is a true statement. Our variable disappeared, and this is true, so infinitely many for 3b. All right. So here's a problem with a bit of context, a real world type problem to think about quickly. So we're given this whole expression, don't worry about the words, we're going to turn it into equations and then talk about it. So a nature center charges $35.25 for a yearly membership and $6.25 for single admission. Last week, it sold a combined total of 50 yearly passes and single admission for $660.50. So how many memberships and how many single admissions were sold in total? So if we call X the year memberships and Y the single, we would get these expressions here. The number of tickets sold is X and Y. The total was 50. The number in sales in dollars was this number here. Each year pass is 35 and a quarter. Each single admission was $6 and a quarter. So those can turn into equations, and this is the part you have to start writing. X plus Y equals 50 is our first. 35 and a quarter X plus 6 and a quarter Y equals $6.60.50. That is our second equation. So we need both of those two. So now we can work through and substitute and solve for each X and Y. Great. So use our first equation. So let's solve that for a variable. We choose X, so subtract Y on both sides. So we know X is the same as 50 minus Y. If that's true, we can now plug in 50 minus Y everywhere there's an X in our other equation. So we'll substitute that in. So here's where we started with our second equation. But everywhere there's an X, we're now going to put 50 minus Y. So right here, this X becomes 50 take away Y. And now we're here. If you can understand that step, that is the whole idea behind this whole section. Okay? So from here, we'll distribute and simplify and then get our answer. I'm not going to make you write all those steps. I just want you to understand the process. So if we were to simplify and subtract from here, one more if you want to write this step down, we get here, we need to divide away the negative 29. So we have to do that on both sides. So we know Y equals a positive 38. Now if Y is 38, we can substitute in on either equation. So you can imagine looking at X plus Y equals 50, what X has to be if Y is 38. A little bit of mental math, you can solve that, no problem. So if Y is 38, plug that in. So X must be 12. So 12 and 38. You can write that as an ordered pair. And it's useful to think about what that means in terms of the context for this real world scenario. So the Nature Center sold then 12 yearly passes and 38 single admissions. So these kind of analysis is useful for understanding how your business is operating, what's more valuable, what do people like, what do they not like, where do your profits lie. So these are all kind of economic decisions that you can make based on these kinds of operations. So that's just one small example of how being able to substitute using two different equations that are related can help you in a real setting. So with that being said, we have time now to work through these concepts on our own. So let's get to it.